In this video, we're going to talk about a concept called amplitude dilation of the sine and cosine functions. So consider the graph that is shown down here. What we've got here is what appears to be an output of a sine function. So we could write this as something like y equals sine of t. And what this would be is on the x-axis here, or this horizontal axis, we would say that is t, and this vertical axis we would say that is y. And looking at the features of this graph, we can see that the range for this function, so the range could be written as, let's say it is -1 all the way up to 1, and the domain for this function is all real numbers. Now consider that if we wanted to have a function similar to this, but what if we wanted to have it such that the range was either increased or decreased? So consider in this particular graph, we've got a maximum value of +1, and we've got a minimum value of -1 as seen here. So the question at hand, what if we want to increase this? Well, what we could do is we could first, looking at this graph, we can first define these features as the height here and the height down here. We could define that as a variable a standing for amplitude. And down here this would be -a. And if we wanted to find this as a, what we could do is going up to our sine, or our function y equals sine t, we could change this ever so slightly and we could say it is y equals a sine t. And what this would do would be that the variable a just here, this is going to act as a scaling factor on the output of the sine function. So what we would find is that if we had a value of a that is greater than 1, we're going to increase the result of this sine function, or we're going to increase the result of y multiplying the sine function, so this output. And if we had a value of a that is less than 1 but greater than 0, we're going to decrease. So decrease the amplitude of this resultant curve. And finally, if we had a value of a that is negative, what we'd find is that we're going to flip the curve around the x-axis, or mirror the curve around the x-axis. Now, rather than me just saying what's going to happen, let's go have a look at it in Desmos. So what we've got here is we've got our curve, and I plotted it over its original domain. So it goes on to infinity, so all real numbers. And what I've done is this blue curve here, this blue curve represents one period of this sine function. So just one cycle of the circle if we're referring to it from the unit circle. Now notice on the left here, I've got a, and I've set a to 1. So as I mentioned earlier, if we increase it, what we're going to expect is the value of this function to increase. So notice as I increase it, the curve is being stretched or dilated in the vertical axis. So it goes up, and then if I decrease it, it goes back down. And if I increase a to a maximum value of 2, then the range of the function, the range of this function is going to be +a, which is 2, and -a, which is -2. And I'll bring it back down to 1 again, fixing it all back up into its original state. Now consider, what if we want to shrink or compress this curve in the vertical direction? Well, we can decrease a, and this decrease will act like a scaling factor. So when we hit an a value of half or 0.5, the range of the function is going to go from 0.5 to negative 0.5. And we can keep bringing it further and further down. And if we hit 0, then we're effectively multiplying the output of this sine function here by 0, which results in a curve of y equals 0. So it's a complete flat line. Now, the other situation that I spoke of was, what about if we make this negative? What if we feed a negative value into a? What will happen? Well, what will happen is, observe, we feed in a negative value, we reverse or we mirror the curve itself across the x-axis. So if I hit play on a, notice the dilation of the curve. So in summary, what we learned from this video is that by adding a scaling factor of a, we can increase and decrease the range or the minimum or the maximum and the minimum values of the range for this particular function. So over here, rather than being or having a range of -1 and 1, we can change it such that the range itself becomes -a and a. So this is how we would add a variable to do some amplitude dilation.